I've been sharing my process building an alternative to MathQuill, the open source math input editor for the web. MathQuill has an awesome user experience, but a terrible developer experience, which is why I think it needs to be replaced. Last video I shared my first attempt at an internal representation of the math as you type it. This representation failed to consider that what you really need is lists of nodes. It just put one node inside another. So for example, the numerator of the fraction was this radical node, but the problem is I might want to type more stuff after, and this didn't have a good way to do that. There were a lot of ugly workarounds. So it was back to the drawing board. This was my next attempt. As you can see, it starts out with an array, and that array can contain text and it can contain subnodes. And each subnode can contain more arrays. So I'm calling each array of strings and nodes a strand because it's sort of equivalent to a string of text, but a little bit fancier. In this model, cursor positions are represented as positions within the text strings. So before the F, after the F, before the X, after the X, before the equals, after the equals. Unfortunately, the next reasonable cursor position is before the radical, and there's no string there. So I decided to introduce two new rules. One, strands have to always begin and end with a string. That's going to solve the problem we just saw. Additionally, strands must alternate between strings and nodes, which solves a problem of if you have two nodes right next to each other, you need to be able to put your cursor between them. So when you fix this, you do it by adding new empty strings. And then if we look at our cursor positions, everything starts to make sense. Before the radical has a position. Inside the radical, before and after these different characters, before at the beginning of the denominator, inside the parentheses, before the two, within the two, after the two, and after the fraction. It all works. So I built this and I was feeling really proud of myself, and I went to share it on Discord and was immediately hit with a much better idea. Fad points out that if you just have the individual characters be their own node type rather than having strings as a top level thing, suddenly the valid cursor positions are just locations within the node list, within the strand. So now you can see like the character F is just its own whole node rather than just a string. And if we start to look at cursor positions, as I click through these, each valid cursor position is just a location within a strand. So you just go to each strand, find the locations between the different nodes, and everything works perfectly. This is clearly a much better and simpler way. So this seems very obviously like the correct way to do it. So I just clicked through the cursor positions, but we really need to be able to represent them as a data structure as well. And so we got to talk about how to do that. In some cases, it's really simple. This example is just a list of character nodes. And so each valid cursor position can just be numbered, right? 0 is before the 0th item, 1 is before the first item, 2 is before the second, and then we go up to 5 at the end of the array. So we're sort of numbering this. If you look at the strand, the array of characters, there are 5 characters here, and so we number from 0 through the length of the strand inclusive, so that you allow that last cursor position. It gets a little more complicated if you have a node with substrands. Some of the cursor positions are still easy, but we also have to represent these positions within the substrands. And so if we focus on one example here, the English way to say it would be that this position is in the fraction's denominator before the 2. We need some way to describe that, and it's going to be more complicated than just one number. In the fraction, we can sort of say more precisely by numbering the nodes and calling the fraction node 2. In the denominator, we can say more precisely by numbering the strands and saying it's strand 1. And then if we number the positions, we're looking at position 0. And so the English sort of translates to node 2, strand 1, position 0. If it gets even more complicated with deeply nested nodes, we can still do the same process. First, we can identify that we're in the fraction, which is node 3. We're in the denominator, which is strand 1. Inside the denominator are a couple of nodes. We're inside the parentheses node, which is node 0. The parentheses contain one single substrand, so we'll just call that strand 0. And we're at position 2. And so if you lay it all out, these different sort of indices naturally group together. The first group, node 3, strand 1, tells us we're in the denominator of the fraction. The second group tells us that we're in the parentheses inside the content of the parentheses. And then once we narrow down which strand we're in, we have a position within that strand. And so we can just always represent a path like this with a node strand, until you sort of narrow in which strand you're in, and then the position. So I built a working demo of this. It does really work, although it's a work in progress. Down here is the rendered version. I know this is a nonsense equation, and the radical node, which is supposed to be a cube root, really just looks like 3x plus 1, because I don't have the rendering all figured out. That's going to be the next video. But as I sort of cursor through with the left and right arrow keys, you can see I'm able to represent all these different cursor positions. Up at the top is the actual representation of the strand path and the position within that strand, so that's what we were just looking at. And I can hit backspace, I can type things, and so it all actually works pretty well. If I wanted to put a fraction inside the fraction, I could do that. Maybe I want to turn this into 1/2 in the denominator. That's pretty cool. I even have matrices working, and as long as I know the number of rows and columns, I'll be able to do fun behavior like up and down arrow keys, although I haven't implemented that yet. So this is where we're at now. I think we have a pretty nice model of how to represent the content, and we have a nice way to represent cursor positions. And so next up is going to be better rendering and more sort of manipulation.